Welcome to The Explainer. Today, we're tracing the exact historical spark that ignited the modern world of artificial intelligence. To really understand AI's current trajectory, we have to look back at the precise moment it transitioned from an abstract sci-fi concept into a legitimate, organized scientific field. So, let's start with a provocative question. How did we get from the clunky, room-sized computers of the 1950s, which were, let's be honest, basically just giant calculators, to the dynamic, AI-driven world we live in today? It definitely didn't happen by accident. It all began with a bold vision from a very small group of ambitious thinkers who truly believed they could decode the human mind. To understand this incredible journey, we're going to trace the timeline. We'll start with the pre-1956 landscape and that legendary 1955 proposal, then look at the Dartmouth Workshop itself, its immediate aftermath, and the massive technological legacy it left behind. All right, part one, sparking artificial intelligence and the pre-1956 landscape of thinking machines. Understanding the intellectual fragmentation of the early 1950s is absolutely essential to appreciating the breakthrough that was about to happen. Get this, the actual term artificial intelligence didn't even exist yet. Early researchers were using a totally scattered variety of names to describe thinking machines. We're talking concepts like cybernetics, automata theory, and complex information processing. With no unified identity, you had all these brilliant minds across the country working in completely isolated silos. Well, a young Dartmouth math professor named John McCarthy realized this fragmentation was a huge problem. He specifically coined the neutral term artificial intelligence to unify all these competing ideas under one single umbrella. He deliberately wanted to avoid the narrow constraints of automata theory and entirely sidestep cybernetics. That was a term heavily focused on analog feedback and famously dominated by the very assertive mathematician Norbert Wiener. Basically, McCarthy just needed a fresh start. Moving on to part two, the visionary 1955 proposal and setting an audacious goal. To really appreciate their audacity, just consider this rapid timeline. Nathaniel Rochester had only just designed IBM's first marketed computer in 1948. Computing was literally in its absolute infancy. Yet, by 1955, these pioneers were already proposing machines that could simulate human thought. It was a momentum that would lead Arthur Samuel to coin machine learning just a few short years later in 1959. The crucial point here is perfectly captured in their core conjecture from the proposal they submitted to the Rockefeller Foundation. It boldly stated that every aspect of learning or any other feature of intelligence could in principle be so precisely described that a machine could simulate it. They were actively proposing to figure out how to make machines use language, form abstractions and concepts, and even improve themselves. And the immense interdisciplinary brain power behind this proposal was unprecedented. You had John McCarthy, Marvin Minsky, Nathaniel Rochester, and Claude Shannon. They essentially brought together theoretical mathematics, information theory, and cutting-edge corporate computing to form the founding fathers of AI. It was an intellectual dream team. So, to make this all happen, McCarthy and Claude Shannon approached the Rockefeller Foundation's Robert Morrison. They requested funding for a summer seminar, but one specifically designed for a highly focused group of just 10 brilliant minds. They figured that by gathering exactly the right people in one room, totally free from everyday distractions, they could make some genuine breakthroughs. Which brings us to part three, the historic 1956 summer, often called the Constitutional Convention of AI. So what exactly was this gathering? Well, rather than a rigidly directed research project, the Dartmouth Workshop was essentially an extended, dynamic brainstorming session that ran for roughly 8 weeks. Held way up on the top floor of the Dartmouth Maths Department, participants sort of came and went between June and August. They dedicated their days to wide-reaching discussions on the relationship between human and machine intelligence. And beyond those 4 founders, the attendee list was packed with luminaries from incredibly diverse backgrounds. Ray Solomanoff kept the primary notes, sitting right alongside computer science pioneers like Alan Newell, Herbert Simon, and Arthur Samuel. Even the brilliant mathematician John Nash was there. This entire group, which even included neurophysiologists and psychiatrists, firmly believed that thinking was absolutely not strictly biological. Now, this is fascinating and maybe a bit humorous in hindsight, but they optimistically anticipated solving the major hurdles of human-level AI in just a couple of summers. Obviously, they vastly underestimated the sheer mind-boggling complexity of artificial general intelligence, but you know what? That raw, visionary optimism was exactly what was required to get the entire field off the ground in the first place. Okay, part 4, birth of a new field and the immediate aftermath. These summer brainstorming sessions acted as a massive catalyst. They initiated very specific research directions that would go on to dominate computer science for decades. We're talking about sparking the rise of symbolic methods, developing early expert systems focused on limited domains, and deeply exploring deductive versus inductive logic. The attendees took that initial spark from Dartmouth and practically ignited the world. The momentum from those 8 weeks established entirely new AI research institutions. It directly fueled breakthroughs like McCarthy's invention of the Lisp programming language, Marvin Minsky's later establishment of the MIT Media Lab, and the creation of dedicated, heavily funded AI labs at Stanford and Carnegie Mellon. The entire academic infrastructure for AI was born right there. Finally, Part 5, Legacy and Future Echoes, looking at the unfolding potential of 1956. It's wild to think about, but the thematic breadcrumbs dropped back in 1955 perfectly predicted the evolution of today's technology. Modern deep learning algorithms, natural language processing, computer vision, and advanced autonomous robotics, they all trace their conceptual lineage straight back to the shared vision of those pioneering researchers. And what's truly remarkable to me is that even in its infancy, the workshop recognized that building intelligent machines required careful thought about the societal impact. They saw the absolute necessity of interdisciplinary cooperation to manage the sweeping technological shifts that intelligent machines would bring. They were laying the conceptual groundwork for how we navigate the integration of automation and computation into our everyday lives, even back then. So, as we wrap up this explainer and reflect on this incredible history, I want to leave you with a provocative thought. Given how incredibly far we've come from those clunky 1950s mainframes, will we ever truly achieve the human-level artificial general intelligence that those pioneers dreamed of in the summer of 1956? Or will the beautiful, intricate complexity of the human mind always remain just a little bit out of reach? It's a massive question, and it's one we are still trying to answer today.